Hello viewers, welcome to BakoMaths, and today's lesson we'll be looking at the division of logarithms. And if you have not subscribed to this channel, kindly subscribe so that when we release a new video, you'll be the first person to be notified. Now let's get started. So in example 1, it says that simplify logarithm of 125 divided by logarithm of 25. Now to simplify expressions involving the division of logarithms, we are first going to express each number as an exponent with a common base, and then from there we are going to apply the product index law to solve. Now this implies that we are going to express 125 as a common base and exponent. The same thing applies to 25. So to solve, then we are going to write our question as the logarithm of 125 divided by the logarithm of 25. Now in logarithm, we said that if we have a logarithm and the base is not indicated, we have to know that that logarithm is in the base of 10. So it implies that the logarithm of 125 has a base of 10. The same thing applies to logarithm of 25, which has a base of 10. Now 125 can be expressed as 5 exponent 3, which means 5 times 5 times 5 gives us 125. It implies logarithm of 5 exponent 3 divided by, now logarithm of 25, that is taking 25, it can be expressed as 5 exponent 2. So you have logarithm of 5 exponent 2. Now applying the product index law, it implies that we are going to write this 3 as a coefficient to the logarithm. The same thing applies to 2, which is also going to be written as a coefficient to the logarithm at the denominator. So if that's the case, then we have our solution as 3 log 5 divided by 2 log 5. Now we can see common logarithms that are going to cancel out. They can cancel out if they have the same base, and here's the case. We can see that they have the same base of 10, so we cancel that and we cancel that. So at the end, our answer now becomes 3 out of 2. We have here 3 out of 2. So this is it. Now let's try the next example. So in example 2, it's just like the first one we did. It says simplify log 256 base m divided by log 64 base m. Now it implies we have to express 256 as a base and exponent. Then we apply the product index law. Now looking at 256, we can express it as 4 exponent 4. That is, we have log 256 here divided by log 64, not forgetting that they all have the base of m, so we have to indicate it base m here. We have base m here. Now like we said earlier, 256 can be expressed as 4 exponent 4, so that is logarithm of 4 exponent 4 base m. That is for 256 divided by the logarithm of 64 can also be expressed as 4 exponent 3. So you have 4 exponent 3 here, base m. Now using the product index law, that is coming from the laws of logarithm, then we can write it as 4 log 4 base m divided by 3 log 4 base m. Now we can see that log 4 base m takes log 4 base m at the denominator out. So at this end, we have our final answer as 4 out of 3, and that becomes our solution, 4 out of 3. So this is how we solve questions like that. Now let's try the next set of questions. So that is in example 3. It says that we simplify logarithm of 27 divided by logarithm of 6 minus logarithm of 2. We shouldn't forget that this is in base 10 because the base has not been indicated. Now we have our question as the logarithm of 27 divided by the logarithm of 6 minus logarithm of 2. Now clearly we can see that 27 can be expressed as powers of 5. Sorry, powers of 3. That is a base of 3 and then an exponent. So when we look at logarithm of 6, it cannot be expressed as powers of 3. The same thing applies to 2. So it means that before we can express 6 and 2 as powers of 3, we first have to break this down. That's the denominator part, so that at the end we can get something that we can express in terms of powers of 3. Now applying the laws of logarithm, then we have here as logarithm of 27 divided by writing the denominator part as a single logarithm. Since they are subtracting, then we are going to divide. That is from the laws of logarithm. So we have log 6 divided by 2, and since they have the same base 10, we leave it. Now we can see that 6 divided by 2 gives us 3. So we maintain log of 27, and then we divide 6 by 2. So at the end we have log of 3. Now, like we said earlier, 27 can be expressed as 3 exponent 3, and then we maintain the logarithm of 3. Now at this point, we can see that the numerator part, log 3 exponent 3, can be expressed using the product in this law, which means we have 3 log 3, and the denominator part we have log 3. Now at this point, we can see that log 3 is going to take log 3 out, and at the end 3 divided by 1 gives us 3. So it is very simple. Now let's try the next example. Now we have example 4, and it says that we should simplify log 4 base 2 divided by log 27 base 3 minus log 25 base 5. And at this point, if you have not subscribed to BakoMaths, kindly spend a moment or a minute and subscribe. Now with this question, we can see that they all have different bases. So applying the laws of logarithm directly may not work, or it's not going to work, since they all have different bases. So it implies that we have to break it down by expressing them in their respective exponents and bases, so that we can apply the product in this law in solving. Now we have our question written as the logarithm of 4 base 2 divided by the logarithm of 27 base 3 minus the logarithm of 25 base 5. Now, like we said earlier, 4 can be expressed as 2 exponent 2. So you have logarithm of 2 exponent 2 exponent 2, sorry, let's clean it and write it well. So you have the logarithm of 2 exponent 2 divided by, now 27 can be expressed as 3 exponent 3. So you have logarithm of 3 exponent 3 base 3. And shouldn't forget that the numerator has a base of 2. So that is base 2 here. Good. Now, when we look at 25, it can also be expressed as 5 exponent 5. That is powers of 5. So you have logarithm of 5 exponent 2. And then you have our base of 5 here. Now, with the product in this law, then we are going to express the numerator as 2 log 2 base 2 divided by the denominator. We are going to have 3 log 3 base 3 minus, at this side 2, we are going to have 2 log 5 base 5. Now we said that the logarithm of a number to the same base gives us 1. So with the numerator, logarithm of 2 to the base 2 gives us 1. So it means we're going to have 1 here, divided by logarithm of a number to the same number gives us 1. So we are going to have the numerator, you're going to have 1 here, minus, so the same thing implies to this one, log 5 base 5 gives us 1. Now at this point, we have our final answer as 2 divided by 3 minus 2. And when we simplify that, we are going to have our final answer as negative 4 out of 3. And this is how we can simplify this question. Now, having known this, let's try the next set of questions. So we have here as example 5, and with example 5, it says logarithm of e exponent 3 minus logarithm of e divided by logarithm of a. Now they all have the same base of 10, so applying the laws of logarithms works. They don't have different bases. So without wasting time, then we have our logarithm of a exponent 3 here minus logarithm of e, and then we have logarithm of a now divided by the log of a. Now we can see that the numerator, since they all have the same base and then they are subtracting, we can write it as a single log by dividing the argument. That is logarithm of, so you have a cubed divided by e, and then at this numerator we have logarithm of e here. Now we ask ourselves what can be done. We can see that a exponent 3 is being divided by e, which means this e has an exponent of 1, so it cancels off and goes into a exponent 3 2 times. So we have a exponent 2 here. So if that's the case, then we are going to have the logarithm of a exponent 2 divided by the logarithm of a. Now considering logarithm of a exponent 2, by applying the product in this law, we can express it as 2 logarithm of e divided by the denominator logarithm of e. Now at this point, since they have the same base and the same argument, we can take them off. They are going to cancel. So at the end, our final answer now becomes 2. So we have 2 here. So that is that. Now let's try the next example. Now in example 6, it says that simplify log x exponent 3 divided by log x. So simplify log x exponent 3 minus log x, all divided by log x exponent 2 minus log x. So it's just like the previous example. So you can pause the video and try this. Now we have our question as the logarithm of x exponent 3 minus logarithm of x divided by the logarithm of x squared minus logarithm of x. Now they all have the same basis. So once they have the same basis, then the idea of applying the laws of logarithm must work. So by applying the laws of logarithm, since they are subtracting, they have the same base, we can write it as a single log by dividing the argument. So that is logarithm of s cubed divided by x. Now we have here, so in the same way, we can also express the denominator part as such, logarithm of s squared divided by x. Now at this point, we can see that this s cubed, the x at the denominator can go through the s cubed at the numerator. So at the end, we have here as logarithm of s squared divided by, so when s cancel s squared, we are going to have x here. Now it implies the numerator can be expressed as 2 logarithm of x, and we maintain that of the denominator log x. Now what do we see? We see common logarithms and arguments, so we cancel that. And at the end, our final answer now becomes 2. So that is very simple. Now let's try the last set of questions for today's video, and that happens to be example 7 and 8 respectively. Now in example 7, it says that simplify logarithm of 16 base e multiplied by logarithm of 27 base e, or divided by logarithm of 9 base e multiplied by logarithm of 64 base e. Now with this, since they all have the same basis, applying the laws of logarithm works so perfect. But we can apply the laws of logarithm by adding the argument, yes. But we can see that the 16, 27, 9, and 64 are numbers that can be expressed as powers of numbers. Numbers that can be expressed as base and exponent. So we are going to use that procedure before we follow up with the laws of logarithm. Now it means that we have our solution as log of 16 base a multiplied by log of 27 base a, all divided by our log of 9 base a multiplied by the log of 64 base a. Now we know 16 can be expressed as 4 exponent 2, so you have logarithm of 4 exponent 2 base a, and then the same thing applies to 27, which can be expressed as 3 exponent 3 base a, all divided by, now 9 2 can be expressed as 3 exponent 2 base a, and then that of 64 we know it can also be expressed as 4 exponent 3 base a. So now we can see that the product index law is very important when it comes to the division of logarithms. So we are going to apply that here, and at this point this log 4 exponent 2 base a can be expressed as 2 logarithm of 4 base a, and then we have here as 3 log 3 base a, and when we come to the denominator part, then we have that is log 3 exponent 2 base a can be written as 2 log 3 base a multiplied by 3 log 4 base a. Now at this point we see some similarities and we can work with that one. We can see that there is log 4 base a here and log 4 base a here, which means they are going to cancel out. The coefficient 2 and the coefficient 3 are going to be maintained because they are not the same. But when we look at log 4 base a, there is another log 4 base a here, so they are going to cancel out. Now we are left with 2 and 3. Now when we come here to, we can see log 3 base a and then another log 3 base a here. So that's what we have. So they cancel out, and at the end we are left with 2. At the numerator we can see we are left with 2 and 3, and they are multiplying, so we have 2 times 3 here divided by the same thing at the denominator. We can see 2 and 3 here, that is 2 times 3, and when these two multiplies, then we are going to get at the 6 out of 6, and 6 out of 6 gives us 1, and that becomes our solution. Now let's try the last one. So the last one is talking about logarithm of 81 times logarithm of 36 divided by logarithm of 216 times logarithm of 3. We can see that they all have the same base of 10, so we can apply the laws of logarithm. But before that, we know 81 can be expressed as powers of 3. The same thing applies to 36, which can be expressed as powers of 6. 216 can be expressed as powers of 6. So if that happens, we can do that before we applying the laws of logarithms. Now, remember we have our question as the logarithm of 81 multiplied by the logarithm of 36, and not forgetting that they all have the same base of 10. Logarithm of 216 multiplied by logarithm of 3. Now we can see that, like we said earlier, 81 can be expressed as 3 exponent 4, and that of 36 can be expressed as 6 exponent 2 divided by, now 216, like we said, can be expressed as 6 exponent 3, but 3 is 3, so we leave it like we see here, so we have log 3 here. Now we continue, and we can express the numerators using the product index law as 4 log 3 for the term at the left hand side, and we come to the right hand side, we're going to have 2 log 6, all divided by, at the denominator we are going to have 3 log 6, and then multiplied by the logarithm of 3. Now I believe you can see some common terms here and they can cancel. Yes, so we can see log 3 here, we can see log 3 here, and we can also see that there is log 6 here and log 6. We are cancelling based on the fact that they have the same the same basis. That is base of 10. That's why you are cancelling. Yeah. So, and then they have the same argument as well. Now, if that is known, then we can see that we are left with 4 and 2 at the numerator. So write them 4 times 2. And then at the denominator 2, we can see that there is 3 and 1 here. So 3 times 1 gives us 3. Now we ask ourselves, what is 4 times 2? We all know 4 times 2 is 8. And we leave the denominator 3. It means our question has the final answer as 8 out of 3. So this ends today's video. And we end here. And so thanks for watching. Kindly like, comment, subscribe, and share. See you in our next video. This is BakoMaths, thinking beyond infinity.